Okay, when we are solving exponential equations, we will have two strategies. Okay. Strategy number one. If we have an exponential equation where we have our variable as the exponent, if on the left-hand side and on the right-hand side we have bases that are exactly the same, they will cancel each other out, and all you will have left are the powers. Okay? Now, I don't want this to throw you. You will not have an x and a y. You will just have an x. This is just kind of a placeholder, okay, for whatever this exponent is, okay? So essentially, if you have two bases that are the same, they essentially cancel each other out, and you will only be left with what the powers are. Okay? Strategy 2, which we've actually kind of already done. If we have an equation, if a equals b, now you should know that by the definition we have an exponent somewhere in here. Okay, they're just not showing that. If I have an equation, I can take the log of both sides, which is what we did on the warm-up. Okay, I'm not changing the equality because I'm adding a log to both sides. This then will enable us, the strategy behind this one is if we take that log, we will be able to use our power property. Okay? We do this because we use our power property. Okay, so those are the two strategies. Okay, I'm going to start with this one. We have 9 to the 8 minus x equals 27 to the x minus 3. Okay, and we're going to solve this for our x. So you notice there's no x and y, okay? We just have one variable. We are going to use strategy 1. Okay. And remember, strategy 1 is I have the bases are equal to each other. Okay, the bases are equal to each other. Well, they're not right now, right? I have a 9 and I have a 27. Okay, but I do know that 9 and 27 are multiples of what number? 3. Okay, so I'm going to take that 9 and I'm going to rewrite it as a base 3. So if I took the 9, I wrote it as a 3. What is the power that I raised 3 to give me a 9? 2. So I'm going to rewrite 9 as 3 squared. That squared is a power. He is now up with the power that is already there, which is our x minus 8. And then I go to my right-hand side. I need the same base of 3. What is the power of 3 that will give us a 27? 3. So I'm going to change 27 to 3 to the third power. That power of 3 is up now with the power that was already there. Whoops. X minus 3. Okay. So based on your strategy, what's going to happen to those two bases? They cancel each other out, so they're out. So we take them out. So we are left with just the exponents. Okay? So on my left-hand side, I'm left with 2 times 8 minus x. So we'll go ahead and multiply that out. What would that give us? 16 minus 2x. And over here we would get 3x minus 9. Okay? Now we have our x. He is not a variable, exponent anymore. He's down in, it has been brought down into the equation itself. Now you solve for x. So solve for x. Okay, you ended up with x equals what? 5. So if we went over here and did a quick check, we would have 9 to the 8 minus 5, and 8 minus 5 would be 3, equals 27 to the 5 minus 3, or that would be 27 squared. So does 9 cubed equal 27 squared? Yeah, because they're just those multiples of 3. What is it, 729?
Yeah.
I think, yes. Okay, so just a quick check. Any questions on that one? Okay, let's try another one. Yeah, it's, as long as you know the right rules, they are not really that hard. Here's our check. There's our check. Okay. All right, we're going to take 4 to the x minus 1 equals 5. 4 to the x minus 1 equals 5. Now, this is different from our first one because 4 and 5 are not multiples of each other, right? You agree with me, yes or no? Yes. Okay, so this case, we're going to be forced into our strategy 2. Strategy 2. Okay, and strategy 2, remember, is what we did on the warm-up. We're going to take the log of both sides. So let's do that. So we're going to have log of 4 to the x minus 1 equals log 5. Okay, right now that variable is unreachable because he is embedded or inside the log. How can we get him out? Divide? No, not divide. Move him to the front. That's our power property, right? We're going to use our power properties. We're going to move him to the front. And then he becomes a what? He goes from being a power to being a multiplier, right? Multiplication. So we move him to the front. So now we have x minus 1 times the log of 4. And our right-hand side, we haven't done anything yet. Okay. So like on the warm-up, how are you going to solve that for x? What are you going to do? Divide what? Okay, so we're going to divide the log 4 out of both of them. Very good, thank you. Okay, so those will cancel. So we'll have our x minus 1 equals, you will have to put this in the calculator. Can anybody tell me what they get?
1.12 or 1.2.
I think it's 1.6. Yeah, I think it's 1.161. Let me see how you put it in the calculator.
Yeah, it was just Alice's
Okay.
me.
Do what?
Having bad allergies, really bad allergies.
Yeah, they're bad right now. All right, so what is our x on this one? We're going to move the 1, yes. So it's just going to become 2.161. And then let's come over and do a quick check. So 4, x minus 1, that's just going to be, we're just back to the 1.161. Is that going to give you approximately 5? Yes, and it will when you check it. Let's get through here. Oh. Okay, I want you to work this one. If we use strategy 1 and we do a rewrite, we would have, for the same base, we would have 3 to the 2x. 27 we just did earlier, which was 3 to the 3rd power. Therefore, our bases cancel. We get 2x equals 3, so x is 1.5. Okay? A lot of you chose to do the log, which is fine. It's just you are adding a little more work for yourself, but if you get the same answer, it's okay. So you took the log of each side. So you used your power property. You brought your 2x to the outside, and he became a multiplier. And then I saw you guys divided out your log 3. And you got 2x equals log 27 divided by log 3. I think you got as a 3, right? Those of you that did it that way. So look how much work you had to get here, okay? It'll work, right, because you're still going to end up with that 1.5, but be smart about these. Think about these before you just jump right into that log, because if you changed that 27 to a base 3, look how much quicker you got your answer. All right, good job. Any questions on that? Okay, let's do one more, and then we'll move on to our logs. Here's our check. All right, do this one. Okay, this one you did not have an option, right? This one you had to go ahead and take the log of both sides. Okay. And then that then enables you to do that rewrite, that power property, bring that forward. Okay. And then you divide out your log 7. When you divide that out, remember that this was initially a negative x. So when you divide that, you got that positive 1.565. You cannot leave the negative, so make sure you take that last step. And you got a negative 1.565. All right? Any questions on that one? Okay? So strategy 1, strategy 2, okay, for your exponential equations. All right? Any questions before we move on to our logs? Okay. All right, so let me get... Okay? So essentially the same as the exponents. If we have the bases that are the same, they do cancel each other out, right? And we just have what's inside. Now, when we are working with the log equation, just like we did a second ago, if your variable is embedded inside of the log, we cannot get to him. So in order to get to him, we have to figure out how to get rid of the log. Okay, so let's try one. Can I take this off? We still... Okay. So we're going to start with this one. We have log base 6 of 2x minus 1 equals negative 1. Okay, this is a little simple one because we're not really having to apply or bringing it together as a single log. We're already at that single log. So we're ready to essentially start to solve this thing. We kind of have our other steps already done here. Okay. Looking at your properties that you learned last week. Okay. That x is inside this log of base 6. Okay? I can't touch it. So here's what I'm thinking. Well, I could get to that x if I did not have this log base 6. Okay? So, how can we get rid of that log base 6? What would cancel a log base 6? Look at your properties. What would cancel a log of base 6? So to cancel out this log base 6, we need another base 6. So that is exactly what we're going to do. So I'm going to come over here. I'm going to add a base of 6 here. And I'm going to add a base of 6 here. Now, when you do that, here's what you need to understand, because I know this looks a little strange to you. When you add a base into an equation, into a log equation, essentially what you are doing now is you are making whatever you had here, these are now exponents. Okay? These are now exponents. Okay? So now I have 6 raised to the log base 6 of 2x minus 1 equal to 6 raised to the negative 1 power. Okay? So if you add in a base, whatever you had there has now become an exponent. Okay? All right. So now we're going to proceed. So if I have a base 6 and a log base 6, your property, your inverse property tells you that they cancel each other out, so they are gone. So what we are left with on this side is just the 2x minus 1. Over here, we are left with 6 to the negative 1 power. 6 to the negative 1 power is really what? What does the negative exponent tell you to do to the 6? Drop it down. Okay? Now, solve that for x. Okay, so we got 0.58, x equals 0.583. All right, let's see if we have another one we can look at. A little extra time. Let's go with this one. We have log base 4 of 100 minus log base 4 of x plus 1 equals 1. So here you're starting off with 2 separate logs. So the first thing you're going to have to do is use your properties. Okay? And you need to bring them together as a single log. All right? So you have log base 4. You have subtraction. How are you going to bring those together? Division. Okay? So that would be log base 4 of 100 divided by the x plus 1. If you want to, you can put it in parentheses. Okay? The problem we had with the last one is the same now, and that is that our variable is embedded in our log base 4. So I want to get rid of my log base 4. How do I get rid of it? Add another base 4. Yeah, inverse property. So we're going to add a base 4 to both sides. Okay, and remember when you do this, now all of this and all of this, these have become the what? These are now the exponent, right? So you have 4 to the log base 4 of 100 divided by x plus 1 equal to 4 to the first power. Okay? So then, now let's apply our inverse, very powerful. Our bases cancel each other out. So that's kind of a common thing with your logs and your exponents. So we have 100 over x plus 1 equals, what's 4 to the first power? 4. Okay. And now you're ready to solve. No, because that won't get the x plus 1 out of there. We need to get the x plus 1 out. Yeah, you multiply both sides by the x plus 1. Okay. So that means your x plus 1's cancel. You're left with 100 equals 4 times your x plus 1 would be what?
4x plus 4.
Plus 4, and now you're ready to solve. Okay. X equals 24. You can go back and do a quick check. Any questions on that? Okay. All right, we'll go ahead and